Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on March 3rd, 2026, just 2 days ago. It introduces a collaborative training framework where diverse AI agents share verified data to learn from each other, outperforming the GSPO baseline by 3.3% while using only half the rollout cost. The paper is titled Heterogeneous Agent Collaborative Reinforcement Learning. And, as we'll see later, the implications for making model training more efficient are quite significant. So, Figure 1 illustrates the core difference between this new approach and existing paradigms. At the top, traditional multi-agent reinforcement learning requires agents to act together as a system, coordinating their actions to get a joint reward. At the bottom, knowledge distillation typically relies on a one-way transfer from a teacher to a student. In the middle, however, the proposed heterogeneous agent collaborative RL framework allows diverse agents to execute tasks independently, yet they still share verified rollouts during training to mutually improve. Well, Figure 2 details the actual algorithm, called Heterogeneous Agent Collaborative Policy Optimization. On the left, the workflow shows Agent 1 and Agent 2 sharing data through the dashed lines, so each learns from the other's experiences. To make this effective, the center section introduces mechanisms like the smooth accuracy ratio, which handles capability differences between models. It also applies exponential importance sampling, which reweights data to prevent unstable updates when strategies diverge. Finally, the radar charts on the right confirm the impact, showing that this approach improves average accuracy by roughly 2.5% across reasoning benchmarks. Moving to the results, Figure 3 plots training accuracy across 3 distinct settings. The red curves represent the proposed collaborative method, while the blue curves show the single-agent baseline. The top row compares a base model against an instruct-tuned version, representing heterogeneous states. The middle row tests different sizes, pairing a 1.7 billion parameter model with a 4 billion one. Finally, the bottom row pairs different architectures, Qwen and Llama. In all scenarios, the collaborative approach consistently yields higher accuracy, demonstrating that diverse models can effectively guide each other. Alright, while Figure 3 plotted the learning curves, Table 1 details the final performance across 7 math benchmarks. The results are grouped into 3 sections based on the agent pairing. In the top section, where a base model collaborates with an instruct version, the proposed HACRL algorithm reaches an average of roughly 76%. This beats the standard GSPO baseline at 68%, and notably, it also surpasses the resource equivalent baseline, GSPO times 2, which uses the same amount of data. Comparing this to the naive row, which drops to 58%, we see that simply sharing data without the capability-aware corrections is ineffective. Wrapping up, this research proves that diverse models do not need to learn in isolation. By sharing rollouts through heterogeneous agent collaborative policy optimization, agents of different architectures can mutually boost reasoning performance while cutting data costs in half. This points toward a future where distinct AI systems actively co-evolve. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.